malpractice. This topic is very interesting for the software industry in Thailand because our government and our college are focusing on software quality process as well as. So this is a good opportunity for us to join in this session. Hopefully, after the end of today, we will have a good collaboration, either in the form of sharing experience or collaborating in the future research and other academic activities. Again, thank you for joining us today and welcome, Dr. Claude.
Thank you very much. Thank you very much for the invitation.
Okay, thank you, Dr. Aziz. I think this is a good time. From now on, Professor Claude will share the lesson with us. Who has a question or maybe come later, you can give me the question via the chat or maybe ask them directly to Professor Claude. It's okay. So I think we can start from now, Professor.
Thank you very much. Thank you for the invitation. I must say that I had the pleasure to visit Thailand at least 6 times. I went to Bangkok 3 times for ISO meetings, and I went to Chiang Mai to teach at the Chiang Mai University about 12 years ago. I was invited to teach a software quality assurance course in intensive mode over 3 weeks, and I did that twice. So it was very, very interesting. So I hope that once the pandemic is finished, that we'll have, again, the pleasure to travel and visit different countries. So this morning, we'll be talking about software engineering standards and teaching, right? So let's start. A few words about my university. ETS is an engineering school in Montreal. We have about 11,000 students, and of which about 2,000 are in software and IT engineering. One very specificity of the ETS is how the undergraduate students have to go in industry for 3 internships. So for 3 sessions, not consecutive sessions. So as an example, they come to class for 2-3 semesters, then they go to a company for 1 semester, they come back for 1-3 semesters, and then they go back until they have done all their education and all the 3 internships. And they are employed by companies. We have thousands and thousands of companies because, as you can see, because we have a large number of students, we need a large number of companies that will be hosting our students for 1 semester. But it is a win-win combination where students can apply the knowledge that they've learned in class, and company will host potentially a future employee, a future engineer. ETS has won a few years ago an ISO award because of the contribution of the professor of the software and IT department in standardization. So we have been participating, like myself, as an expert of Canada since 2002, and other professors have been either editors, project editors, chair of SC7, and we have written many books and articles about that. And also we have integrated the teaching of standard in our curriculum. So we were given a prize of $19,000 to split amongst ourselves. So a few words about my involvement in standards. So I've been in the military for a few years. I was a teacher or professor at the military academy, where I was the initiator of a master's degree in software engineering. This is back very, very far. This is back in 1988, 1989 timeframe. So the first graduates in Canada of a master's degree in engineering were at the military academy back in 1991. And then if you go to the left, I was also involved in managing the engineering of systems engineering, software engineering, and project management processes. And in year 2000, so that's 21 years ago, I joined ATS as a professor. And on the right side, you can see that I've been also doing some consultation with Bombardier and Subway of Montreal. So that's, and during all those years, either in the military or with Oerlikon Aerospace or with ATS, I've been involved in applying standards or leading the development of standards. So today, after an introduction, we'll talk about what I call an impossible scenario, some observation about software engineers, why bother with standards, quality and productivity issues. I will be talking about 29110 series and the teaching of 29110, a survey that we did with software engineering professors, and how can we help professors to teach software engineering standards. So let's start with the introduction. So in 2018, I was in a meeting in New Delhi, in India, a C7 meeting. A C7 committee is responsible for systems and software engineering standard for ISO. So one of the working group is my working group 24, and we were presenting, each of us of the panel, we're presenting what we were doing. And at a certain point in the audience, someone asked me the question, could a software engineering professor who do not teach software engineering standards to software engineering students be accused of malpractice? I was quite surprised when I got that question, because normally we don't talk about malpractice or negligence in academia. So I gave it a thought for a few seconds and I said yes. And I'll explain to you why I answered yes in a few seconds. So you can see the definition on my slide. It's not a legal definition, because it was not a legal debate. It was to talk about the concept of teaching standards and could that be negligence if we don't teach. So the impossible scenario, you can imagine an 8-person company that developed computer control valves that are installed in different plants and chemical companies, as an example. And the contract that was signed with the organization that developed the software asked to use IEEE software engineering standards. So this is not specific to this scenario. Many companies, many large organizations, when they write a contract, they will ask the supplier to develop software according to, in this case, IEEE standard. It could be ISO standard. So when you list standards in a contract, it becomes contractual. In other words, it is an obligation from the supplier to use the standards that are listed when they develop the software. So as an example, and one of the standards that was listed is the IEEE 1028 about software reviews. And the inspections is one of the types of reviews that is explained in the standard. And inspections are peer examination by peer, we mean colleagues, people at the same level, if you want to say it from this point of view. And it is led by a facilitator who is trained in inspection techniques. So for the history, the developer that participated to the development of software was not aware of this standard. So what he did, he inspected, and put it in quotation mark, the software requirement by himself. So it is a contradiction. Right? You can see that this contradicts with what is written just above, because what is written just above is he should have participated with his colleagues, with a trained facilitator, to inspect the requirements. So when they installed when the computer control valve was installed in the chemical plant, one of the valve malfunctioned and it caused damage, right? And one of the technicians had to be sent to an hospital. The supplier was asked naturally to fix the defective software right now. The supplier did not want to correct the software unless the customer paid an additional $50,000. So this is typical situation. Okay? If you want me to do the job, you have to pay me more. So that's what's happening. So the customer that bought the computer control valve decided to sue the supplier of the defective software. In other words, to launch a legal action against the supplier. So at the court hearing, the lawyer requested evidence showing that inspection has been performed according to 1028 standard. So it is the lawyer of the customer. So you can see that the lawyer of the customer is in front of the judge, and it says to the developer of software, can you provide us evidence that you have used 1028. And the supplier could not provide that proof. And the customer lawyers also interrogated the developer and asked him to describe how he inspected the requirements. So evidently, it was demonstrated to the judge that the developer did not use the IEEE 1028 standard to provide to do their reviews. So it became evident that this was the case. So so if an inspection, I said if an inspection had been performed, probably the defects, the defect would have been detected. And once it is detected, it would have been correctly corrected. Okay. And also, if he had performed a 1028 inspection, out of this process, there are evidence that the review has been conducted. By evidence, I mean, normally there is a little one-page report that is produced after a review or an inspection like that, where you list the people that participated to the inspection, what has been inspected, the checklist that has been used, the duration of the inspection, and the number of defects detected. Those are typical information that is captured out of an inspection, such that if an auditor comes in, and in this case, if you have to go to court, you have a proof to demonstrate that you have performed an inspection according to 1028. In this case, the company was not able to provide this information. So the judge decided that the supplier did not fulfill the requirements of the contract. The judge blamed the developer for negligence by not performing an inspection as described in the contract. And the judge ordered the supplier to rework the software, in other words, to make the correction to the defects at no cost, because the supplier was negligent, so there was no way that the customer would have to pay money to fix that defect. So at the court hearing, the judge asked when the software will be delivered to the customer. And the supplier said it's about 2 weeks of rework, because they found that the defect was originated in the requirements. So it means that they have to fix the requirements defect. They have to modify components of the architecture. They have to modify code components. They have to modify also a few test cases, a few test procedures, and retest again, do the unit test, the integration test, the system test, and also update the documentation. So that's why the supplier said it would take about 2 weeks to do those modifications. So outside the courthouse, so just after the judge ruled about the negligence of the company, the president of the company fired the developer, and the developer contacted a lawyer to launch a lawsuit of negligence against the university that he attended. So he launched a lawsuit on behalf of hundreds of students of his university that had not been presented or trained or educated about software engineering standard. And also, hey, because this is what is happening today, he informed his friends over the network, and that information became viral all over the world to professors, students, and also lawyers. Lawyers, because they are interested in making money, okay, out of court cases. So this is the story that happened, and this is what is documented in the article that was published a few months ago in IEEE Computer. And this article was written with a colleague of mine, Mirna Mono, from Mexico. She's a professor over there in the state of Zacatecas, and she's also a member of my working group 24. I'll talk about that in a few minutes. So when we wrote the article, we had a few objectives. One was to promote the teaching of standards as source of knowledge. So see standards as documented knowledge that we have gained from successful projects, and most importantly, sometimes from failed projects, because we learn much more from, we should learn much more from failed projects than from successful projects. Also to provide discussions among software engineering standards, about software engineering standards amongst professors, amongst professors that teach and those that do not teach, such that they can discuss amongst them about professor and students, and also about professor, students, and enterprises, because the bottom line is those students will eventually work for enterprises and or for government organizations. What were not the objectives of the article? We didn't want to trigger a legal debate. This is an IEEE computer article, so it's not an article about legal issues. There are other journals for that. We didn't want to blame professors that do not teach software engineering standards, because there are many reasons, and I'll explain that later on. But we don't want to promote standards as being the silver bullets. By silver bullets, meaning something that can solve all or prevent all the software engineering problems. So standards are not silver bullets, right? They're not miracle. Okay, they will help you a lot, but they're not miracle. So a paradox. So software engineering standards are sources of codified knowledge, proven practices, practices collected from thousands and thousands and thousands of projects that have been done since, let's say, the mid-1980s or something like that. So we have collected that knowledge by consensus. We have developed draft versions of standard. They have been reviewed by experts around the world, and eventually, after a few cycles of review and comments and improvements, standards are being published. So standards support the organization in delivering to their customers all the functionalities with all the quality characteristics within budget and schedule. So it's quite easy to develop the functionalities. It's a little bit more tricky when you add all the quality characteristics like maintainability, portability, security, etc. And when you add the double constraint of budget and schedule, that's even more complex. So software engineering standards are not used or ignored by many professors. And those professors are mandated by their university to transfer proven practices to their students. This is, at least in Canada, and I guess it's the same thing in your country, the mandate of a university is to do research, but also to transfer the knowledge from professors to students. So since software engineering standards are sources of knowledge, then it should be also transferred to students. So the consequence is many students will graduate with a deficit of essential knowledge. And also they will ignore how to use standards as well as their benefit and disadvantages. So my question to you, is this acceptable to students and enterprises? And I guess you can guess what my answer to this question is. So let's talk for a few seconds about what is software. So you may laugh when you see this title, because you say, oh, everyone knows what is software, but let me show you different point of view from different perspectives. So for computer science professor and students, it's debugged code that has been done for a homework, an exercise, or a project. And once the project, the exercise is done, it goes to the recycle bin. That's how it is. We go to the next project or the next exercise. So for many software developers in industry, it is also debugged and partially tested code. For customers that will use the software for a short time, by short time I mean a few months, maybe a few years, they will need also some documentation. And for users, customers that will use the software for a long time, and by long time, if you look at those systems, we mean decades, many decades. And I will show you an example in a few minutes. So you may have systems that have been in operation for 10 years, 20 years, 30 years, 40 years. If you look in the banks, if you remember many years ago, there was the Y2K crisis, the year 2000 crisis, and that's 21 years ago, by the way. And one of the crises was that they wanted to verify if the software was correct to pass the year 2000 crisis. And they discovered that they had millions of lines of code written in COBOL, code that had been written 10, 20, 30 years before. and those people were not around anymore because they had retired, or they have left the company, or they have been promoted to management jobs. And 20 years later, if you talk to people in banks, in the IT department of large banks, they will tell you that they still have software written in COBOL that's been in operation for the last 40, 50 years. Okay, so for those users, they want a lot of documentation, because the knowledge of the people that originally developed the software has to be captured in the documentation, because those people will, as I said, will be transferred, will leave the company, will be promoted. So you have to capture this knowledge in the documentation, and that documentation has to be updated as every time some modification is done to the software. So this is why the list of documents is much longer than the other one. So in the domain I've worked, in the defense and the military domain, we have systems like all over the world that are in operation for 10, 20, 30 years. So at the top of my slide, it's more what I call the computer science mindset, where you write something, maybe not maybe, but you debug it, and you run or execute a few tests. And at the bottom of the slide, it's more what I call software engineering, where you have to engineer the software and think that it has to be maintainable, and it will be changed over the 10, 20, 30 years of operation. And I told you that there are systems that have been around for many years. So here you have the example of the 747, first flight happened in 1969. So probably many of you, if not most of you, were not born yet. Okay, so that's just an idea of how old this is. So they are still, when the 747 are being retired. So 2 years ago or 1 year ago, they took a video in the 747, and they discover a floppy disk reader. So again, maybe many of you don't even know what is a floppy disk. So I point to you, you can see the finger of the operator with that diskette, 3.5-inch floppy disk, which contained, if my memory is right, about 1 megabyte of data. Okay, so that's a very old system. But when the 747 was designed, they used the technology that was available in those days. And if it works, then you don't replace it. Okay, you don't replace a $10,000 or $20,000 subsystem just for fun. If it works, and if it still works, it's still operable, then you keep it. Okay, so when I say systems have been used for many years, and it's the same thing for the space station and even for nuclear weapons used in USA. Until recently, they have been using a floppy disk. So let's look at that slide. Now you may say, maybe you are listening to the wrong presentation, because I'm showing you chemical laws and laws of mechanics, laws of different laws. So my point here is with the laws of nature, the principle of causality. So the same effect always cause the same cause always cause the same effect, right? So if you apply the Ohm law, and I'll give you an example in a few seconds, whether you are in Phuket right now at plus 30 degrees Celsius, or you are in Montreal, where I am right now at minus 7 degrees Celsius, the Ohm's law will work, okay? Whether it is Wednesday or Friday, whether it is applied in the mountains or under the ground, it always works. Okay? And just to illustrate to you, because I want to stress the fact that in other engineering disciplines, the laws of nature are the foundation of the engineering discipline. Okay? And students in school are being taught those laws of nature. And this knowledge is deeply embedded in the brain of engineers, of electrical engineers, mechanical engineers, chemical engineers. So they know that they cannot violate a law of nature. They know that the law of nature is always true within a certain bound, naturally. So laws of the Ohm's law is if you have the equation, the voltage equals the resistance times the current intensity, and gives you naturally a straight curve. And as you can see, the diagram is quite simple, okay? And laws of causality means that depending on the resistance, if you vary either the voltage, the current will vary, or if you vary the current, the voltage will vary, and that's universally being applied. And if you go down deeper into the mechanics or the physics of the Ohm's law, then even the resistance is defined with different components. Eh? Is the electrical resistance is equal to the length of that piece of material, the area, the cross area, and the resistivity of that specific metal, as an example. And if you go down deeper, so here you can see the table for different metal, and you can see that the resistivity will vary, small variation, but if you can think that you can have a 30, 50, 100 degrees Celsius difference, then it is important to take into account those variations. So my message is, in this case, for electrical engineer, they have handbook and they have even software that will make the computation such that when they have the right requirement and if they follow the law of nature, they will always get the right answer. This is not the case in software engineering. Software engineering is different, okay? So would it be conceivable that a professor teaching basic electrical engineering would not teach Ohm's law to their students? That would be a nonsense. You agree with me? No electrical engineer will go through education without being taught what is software, what is Ohm's law, and also doing problems and doing lab experiments to make sure that he has captured not only the theory about the equation, but he had measured that. And as an example, many years ago, I did teach a basic electrical course, and I did teach the Ohm's law with the little setup that I showed you. And it was amazing to see how many fuses were being blown because the resistance, as they were modifying the resistance to draft the curve that I've shown you, when the resistance came close to zero, then automatically the current went very high, and to protect the system from burning, then a fuse will blow. So students capture that this law is always true, and if you try to fool around with the law, then you will be destroying things, okay? Now my question to you is, name a law of nature that is a foundation for software engineering. Think about that for a few seconds. And there are none, okay, there are none. So we rely on the laws of logic and mathematics. So this is, or those are the foundations of software engineering. Laws of nature, laws of logic and mathematics that has been developed by people in computer science, as an example. Okay? So it's very far. Okay? Yes, we need laws of logic and mathematics, but it is quite far from the laws of nature that other engineering disciplines have. So I'll let you read the definition of a standard from ISO. So we talk about consensus. Consensus means that we talk amongst experts, and after long discussions, we come to a conclusion that, as an example, this practices will be documented in standards to improve the likelihood to deliver quality software within budget and schedule. So this is what we mean by consensus. And a recognized body, we mean, as an example, the ISO is a recognized body, and the IEEE is one. So, and there are other ones. So let's have a look at the SWIBOK, the guide to the software engineering body of knowledge. I have been the co-editor of that document which was published by ISO many years ago. So the SWIBOK defines the generally accepted knowledge in 15 knowledge area. As an example, in the requirements and the design, the management, etc., etc. Okay. And there is an annex that lists all the relevant standards to each knowledge area. As an example, if you're teaching software requirements, if you look at one of the annex of the SWIBOK, it will list the standard, the 29148 standards about requirements engineering. In other words, it says that there is some knowledge about requirements engineering, but you should also be reading and learning about the appropriate software engineering standard. And there is also in the 3-bucket clause about professional liability. And it says in that clause that it is vital to adhere to standards, okay, to protect against allegation of malpractice, negligence, or incompetence. So if you are using, or you should be using the 3-buck as one of the framework to develop your curriculum, then that should be shown to the students that one, they have to learn about standards, and one of the reasons is to protect them. Okay, it's also to protect them, and I'll show you an example in a few seconds. So, why is there a code of ethics? The thing is, because of what software engineering students or software engineering professionals do, they can cause harm to other people, or they can enable or influence other people to cause harm. So this is why there is a code of ethics for software engineers. And by the way, it is freely available if you look at the hyperlink at the bottom of my slide, and it has been translated in 9 languages. Now, I'm not sure if it has been translated in Thai, but that could be an opportunity for you to develop a Thai version of the code of ethics. So let's have a look in the code of ethics. So I'm talking about code of ethics. So there are 8 principles, and those principles should be used or applied by naturally by professional software engineers, but also by educators and students. So it's back at the university, or right there at the university, that they should learn about the code of ethics and practice it. Okay? And one of the principles is the principle number 3 about the product, and it says software engineer shall ensure. And I've highlighted the word shall because it means it's an obligation. It's not an option. You don't have any choice. Okay, you have to use standards to develop products, software engineering products. Okay, and it says in clause 3.06, you should work to follow professional standards that are appropriate for the work. And principle number 8 about yourself, it says software engineer shall participate in lifelong learning. In other words, once you graduate, it's the beginning of your learning, right? Because you'll have a career of 30 years, 40 years, 50 years. So you should be learning on a daily basis, and you should be improving your knowledge about software engineering standards. So you should learn about them at the university, and once you graduate, you should be improving your knowledge. So let me read to you a quotation from Jim Moore from IEEE. And I met Jim, I know Jim for back to the 1990, was about that, when I met him the first time. And Jim has been one of the delegates, one of the experts of the United States on SC7 committee. So he says, standards are important because they represent good enough practices, okay? Not because they necessarily represent the best practices, but because they represent good enough practices. And he says, court generally view the application of standard as evidence that engineers did their work with diligence and responsibility. So it's like a proof. If you are sued for negligence, okay, then you can, if you have used the standard and you can demonstrate to the judge that you have used the standard, then maybe you will not be accused of negligence. So if accused of negligence, okay, you as an engineer can see, when I say engineer, I should say in general, you that are developing software, okay, either as a computer scientist or as a software engineer, or even as another engineering discipline like an electrical engineer or mechanical engineer, because maybe you know that in small company, one engineer will play different role. So he could be an electrical engineer, but also he might be developing a few hundred or a few thousand lines of code. So if accused of negligence, if you can demonstrate that you have used software engineering standard, then maybe you'll be okay. So my hypothesis is, if an engineer could be accused of negligence, why could professors that teach to future software engineers that ignore or do not teach standard to their students could not be accused of malpractice. It should work both ways, right? If a professional engineer could be accused of negligence because of not using standard, and if he has not learned standard in academia, then the university is responsible, as well as the professor. Okay, so let's move on. Sad observation about software engineers. An article that was published 2 years ago in IEEE Software. It is a column that had been ran for 10 years. It's called the impact column. And the editor stepped back and he said, okay, what have we learned during the last 10 years that we ran or edited that column? So they say that in software, we feel that it's appropriate to jump to the next fad without learning anything from the previous one. In other words, there is a new programming language and I'll jump on that, okay, because it's new and it is sexy. Yes, it is hot. Let's do that. There is a new methodology. Let's jump on it. And we forget that we have not mastered what we have been learning just a few months ago. Okay, so we're jumping from one fad to another. So we cannot call ourselves an engineering discipline unless also we systematically learn from our mistakes, like other engineering disciplines. Okay, like an example. Okay, if you look at jet engines, the performance of jet engines have increased by order of magnitudes since they've been created 10 years or 20 or 30 years ago. So they have increased the performance in the power of the jet engine, in the noise level, in the efficiency, in the level of pollutions, reliability, etc., etc. But if you want to do that, you have to measure. And unfortunately, we in software engineering have an aversion to measurement. Okay, and it is the opposite of what is happening in other engineering disciplines, because they measure and they learn from their mistakes, or they measure and they learn how to improve the product, how to improve the reliability of a certain product. Okay, we don't do that in software engineering. So if we do not change anything, we cannot expect the situation to improve by itself. Okay? Nothing will improve by itself. On the contrary, things will deteriorate if we let it to chance. So why bother with standards? So we human beings, we all make errors. Okay, except the only people that claim that do not make errors are the politicians. So let's not talk about this. But we, as developers and managers and professors, we all make errors. So let's be clear about that. Okay, and those errors will materialize themselves into defects. Okay, so you make an error, and that error could mean that you'll be injecting one or many defects. And that defect or those defects can lead to failure. And a recent example, Tesla, okay, there's been a recall. And if you read the journal, The Guardian, that published the article 2 weeks ago, it says that there was some problem, okay, and that could trigger the brake system, emergency brakes of the Tesla. So imagine that you're driving on a highway at 160 kilometers per hour, and at your back, you have a big truck that is following you at a safe distance, and everything's clear, the road is perfect, there is no rain, the situation is perfect, and suddenly, for no reason, the Tesla will apply the emergency brake. So you can imagine that the truck at your back will get to you and maybe jump over your car and it will crush you, okay? Or a minor defect, again, published in The Guardian, but 2 days ago, 2-3 days ago, about users, 500 users that could not get to their car because the application that they were using to open the car, unlock the door of the car, was showing a 500 server error, okay? So this is a minor failure, but it is quite annoying for someone that wants to drive, that he has a perfectly operating car, okay? Everything is perfect, but he cannot unlock the door, right? So what we want to do is we want to learn how to prevent errors and we also want to find out how to detect those defects. So on one side, we make errors, and those errors will eventually become defects. So we want to prevent errors and detect defects. And standards can help you to prevent errors and defects. Okay. Again, there is no miracle. It's hard work, but you have to put to use everything that has been developed for you as tools. So talking about tools, when I talk about software quality assurance to my students, or when I give presentation to industry, I say see quality assurance as a toolbox, okay, to develop quality product within budget and schedule. So if you are building a house for your dog, or a little house at the back of your garden, or a family house, or a little medical building, or a sky rise, it's how building, all of them are building something, okay? But you can imagine quite easily that the tools that will be used to build the doghouse are quite different than the tools that will be used to build the medical building, right? Same thing in software, okay? So there is a lot of tools available, and I will show them to you in a few seconds. So you have to select the appropriate tools out of the toolbox. So the toolbox, what I use as a metaphor, if I want to keep in the building metaphor, I use the house of quality. So on the left side, you can see we have references like standards, and this is what we'll be talking today. Defect categories, quality models. We have configuration management practices, reviews and audit practices, verification and validations, etc. And as we move to the right, we have the code of cost of quality. I'll be talking about cost of quality in a few minutes. I already talk about the code of ethics, checklists, risk management, etc. And in a company or a government organization, you have some software quality assurance function. It could be one people that will perform the QA function. It could be a team, or it could be in large organization, a complete department. And all that will happen if there is strong management support. And by that, I mean that management will explain to the people working in a company why SQA practices are important. The management will provide the resources for the implementation of SQA practices, and also will be providing rewards and sanctions for the implementation of SQA. Because some people will be motivated to implement software quality assurance practices. Other people will be reluctant. It's up to the job of management to indicate clearly that whatever has been defined and approved within an organization are the practices that should be used in a daily basis to develop or maintain software. And if you don't agree with this, then you should leave the company and work somewhere else. So the selected practices out of the toolbox will be documented in a quality assurance plan, which could be 2-3 pages, or it could be also documented in a large document, 40-60 page, when you're working on large projects. As an example, when company get the contract to develop, let's say, subway trains, then normally those are hundreds of millions of dollar projects that will be in operation, that will be developed over 2, 3, 4, 5 years. And you could be assured, because I've seen them, that they have many plans, and one of which is the software quality assurance plan. And most of the time, the customer will have in the contract a clause meaning that the customer will approve the software quality assurance plans of the developer. So when we have large contracts, large projects, the customer wants to make sure that you will be following the codes, the best practices that are documented in standard as well as in textbooks. So if you do the things right, then you should have stable processes, capable processes, continuous training and improvement. You will be delivering quality product, and you will have motivated employees. So today we'll be talking about a subset of this box. So as you can see, if we want to cover all the boxes of QA, this is a complete one semester course, a 15-week semester course that we teach at PTS as an example, 3 hours per week in class, plus 2 hours per week in laboratory, plus personal reading and personal homework and personal exercises over 15 weeks. Okay, let's talk about advantages and disadvantages of standards. So here is a list of advantages and benefits, and I'll let you read them. So as you can see, there are a long list of advantages, but as I say to my students, life is a bitch, and for advantages, there are also disadvantages. This is life, okay? But there are ways to reduce those disadvantages. As an example, standards are costly to acquire, but they're much more costly to implement. And there are costs associated with certification. And I'll show you later on that in my working group, we have developed guides that will lower the cost of acquisition of the standard and lower the cost of implementation. And also one of the disadvantages of standard is that they describe what to be done, not how to do it. So standards are a list of requirements of what you should be doing. But many people in small companies, in VSCs, very small entities, they don't have the expertise to translate the what to do in how to do things. So this is why in my working group, we have developed guides, and the guides will list exactly what I'm listing here. It will tell you how to do things. And I'll give you an example in a few minutes. Okay. So an example of the benefits of standard, this is a recent study from the Standard Councils of Canada, and they have measured the gain in productivity and gain in the gross domestic product over a period of time. And as you can see here, there are a quite high gain in productivity and in GDP. Same thing, other countries have also measure their growth in GDP because of the use of standards. Okay, why am I showing this? So the growth in GDP means that within a country, okay, thousands and thousands of companies that have used standards have improved their productivity or the quality, the competitiveness. And so if you look at the global aspect of all those thousands and thousands of enterprises that improve their productivity and the quality, then you can those data, those individual data points will reflect in the national gross domestic product. And this is what you see here. So because one of the bottom line of implementing standard, okay, it's not because it's nice, okay, it's not because the professor told you that. When you get to industry, it's because it brings benefits. Okay? It has to bring benefits, otherwise it has no use, right? So if you do it right, if you select the proper standard, and if you apply the standard correctly, then you should see benefits in increasing in the productivity or the quality or reducing in the development time. Okay, so this is why there is a bottom line. So you have to think about that. So this brings me to the next topic about quality and productivity. So question to you. So I don't know if you're all students or if some of you are people from industry, but I like to ask two sets of questions when I go in industry. Okay. First question is, what percentage of your budget goes into those 4 cost categories? Okay. And the cost category are the cost of execution. So execution means if we were perfect, as I will show you in a few seconds. Let me just switch a slide for 1 second and I'll show it to you. Cost of performance, if we were perfect, 100% will go into that cost category. But we are not perfect, so we do evaluations, we do reviews, we do tests, we do verification, we do audits. And if we are smart, if we are intelligent, then we will try to prevent the errors to be made again. So we'll be improving the training, the methodologies, the tools. We'll be acquiring standards and implementing them. And the fourth cost category is the cost of fixing things, the cost of correcting things. As I said before, if you are in the integration test and you discover that you made an error in the requirements, then you have to modify a few documents before you can retest again. So this is what I call the cost of rework. And my question to you, what is the percentage of your budget that goes into that cost category? Do you have any idea? Let you think about that for a second. So the question I asked to industry when I show this slide, I say, can you provide me with this data, with the data about those four cost categories? And I would say that over 90%, if not 95% of companies cannot provide me with this data. Okay. So I'm saying to them, can you really say that you're managing a project if you don't have those process measures? Okay. And I'll show you why am I saying that. If you go back to the cost of non-conformance or cost of rework, the third one, you will see later on that it is quite significant. We're not talking about 1 or 2%. We're talking about 30, 40, 50, or 60% of the budget that goes into that cost of rework. And the next set of questions that I ask to people when they say that they are providing quality software, I ask them to show me their data. Okay, I say, okay, this is your opinion. I respect your opinion, but please show me your data. Can you provide me the answer to those three questions? What is the density of defect injected by your organization? Defects could be by 1,000 lines of code or by function point or by other measure. Second question is, what is the defect detected by your organization? And the third question is number of defects delivered to your customer. Okay. Most of them cannot provide me answer to this question. So I say, if you cannot provide these product measures, how do you know if you're developing quality product? You have an opinion, but you have no data to support that. So when I don't have data, I will not trust your opinion, okay, until you prove to me with hard data. So let's look at a recent report produced by a consortium in USA, the CISQ consortium. And I provide you with the hyperlink at the bottom. So a report that was produced 3 years ago. And since then, they have produced an update last year. And in 2 weeks, there will be a webinar where they will be introducing the 2022, when I say in 2 weeks, the 2021 report, sorry. So in a fragment of the report, it says most IT and software organizations do not collect data about the cost of quality. Okay? Remember the cost of quality, the forecast of quality that I showed you before. And without those measures, okay, it's hard for people in industry to know what is the cost of poor quality, okay, and to know if the investment, the improvement that I've done is going in the right direction. So let's say that I buy a new tool, a new software tool. I don't have any data to show if it will improve either the productivity, the quality, or both of them, right? This is bad. Now, I hope you're well seated, and I will show you the number that has been estimated in the loss of because of poor quality in USA in 2018. Okay, this is only for 1 year. So the total US cost of non-quality, poor quality, is $2.26 trillion. Okay, $2.26 billion. That's a lot of money. So if you want to read the report, you can download it. Now, in the same report, I like the analogy, the metaphor of the iceberg. The iceberg, if you see, when you see an iceberg, you see just the tip. One ninth or 1/10 of the iceberg is on the top, and the other 8/10 or 9/10 are under the water. So what you see, what is visible, usually visible, are customer problems, customer calls, lawsuits, warranty claims, the QA department, the cost of QA in the testing department, and when you have a breakdown, like what happened with Tesla a few days ago about the servers, okay? It looks like the server went down for a few hours, okay? And what you don't see, okay, are the huge potential for reducing what's under the line. And I'll let you read them. And unfortunately, because of the high cost of poor quality that was shown in the previous slide, you can guess that 95, 98% of companies, you don't look at those hidden costs of poor quality, right? So another point of view, I'll let you read this sentence. I want you to guess what's the number behind my rectangle. $50 to 40%. So that's a lot, okay? That's a lot. So 50% means for every hour that you spent in development, you have to spend one hour to correct the defects. And again, when I gave presentations around the world, I had the occasion to present a workshop in Bangkok a few years ago to people from a large company. And I asked the question again, what is the percentage of rework? And when I showed that to them, the first reaction is, oh, that's big. And when they think about it, okay, when they think about fixing this, fixing that, fixing documentation, losing time, blah, 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 they say, yeah, I think you're quite right. And some people will even say, oh, yeah, I think we even have higher percentage of rework in some of our projects. So again, if you don't change anything, don't expect the situation to improve by itself. Okay, it will not happen. Okay, it will not happen. Okay, this citation comes from an article published over 15 years ago. Okay, if you look at the bottom, okay, you see that I took that from IEEE Spectrum in 2005. Okay, and I would be willing to bet $100 that I can go around company and within a few hours, I will be able to identify company with that 40 to 50% rework. Okay, still today, 15 years after, right? This is a cost of quality curve that I'm using and I've been using for many years. And it shows, and it is from a real company called Raytheon. It's still existing. It is in the high technology area in defense aerospace business, if my memory is right. And you see that there are two curves, the cost of rework in blue and in red, the cost of prevention and evaluation. So as you can see, as you increase the cost of prevention and evaluation, then you can see that you also decrease the cost of non-conformance or the cost of rework. So quality, there was a book written many, many years ago, and the title was Quality is Free. This was quite misleading because nothing is free, okay? By the way, nothing is free. So, but quality becomes cheaper and cheaper to get after you have made the correct investments, okay? Once you have put in place the correct prevention and evaluation practices, then the cost of rework will go down and down and down. An example, so for those of you who know the maturity model, so in those days, they were using the software CMM. Today, it's the similarity with CMMI. So when they started the initiative to reduce the cost of rework, they had 41% rework. And as they improved, as they added prevention and evaluation, it went to 18 to 11 and eventually to 5%. So the bad news is every company has a high percentage of waste. The good news is there are ways to reduce that significantly. Here you can see by a factor of 8, okay, from 41 to 5%. So imagine that you are at 40% rework and your competitor is at, let's say, 10% rework. So it means the difference is 30%. So it means that there is a difference of 30% in profit, or your competitor will be able to offer the product at a much reduced cost to you than you. Okay, so this is the game. Again, the name of the game, the bottom line is revenue and loss, and revenue and loss and profit. Okay, of providing quality software, right? So the message is standard can help you to reduce the cost of non-conformance. Okay? It's not the only tool. Remember the toolbox. Okay, standard are one of the big tools that are essential to the reduction of the cost of rework. So let's have a look at the portfolio of standards for a while. So I told you that there are many committees within ISO, and the committee number 7 is responsible for systems and software engineering standard, and it is presently chaired by India. For the last 3 or 4 years, people from India, from the Bureau of Indian Standards, are the chair and the secretary of the SC7 committee. And for information, Canada has been the chair of the SC7 committee for 10 or 15 years before India. So the actual portfolio, we have about 200 published standards, and 34 are under development. So this is the map of the countries that are participating to the work of SC7. So what you see in blue are the active members, and what you see in orange or yellow are what we call the observing members. And you see at the bottom also that there are 180 members that are registered to the ISO website, to the Working Group 24. So as you can see, except Africa, there is a very, very wide coverage of countries that are working actively with this SC7. So when my working group is developing a new document, as an example, a DevOps guide or Agile guide, the draft is sent to those members, those active members, for review by their experts. And it is these experts that are providing comments to improve our documents. Okay. And this is you can see the evolution of documented knowledge. So the red lines are the total of standards that are being available in each of those years. And the blue lines are the addition. Every year we published 1, 2, 3, 4 new standards within SC7. So what you can see is for the first, between 87 to about 97, it was quite flat. Okay, and from 97 about that, you can see that the steep of the curve changed quite sharply. So in other words, we have been gathering lessons learned from failed and successful projects. And at a certain time, we had critical mass of information to be able to set up working group, gather experts, and eventually come to a consensus about the proven practices that should be imposed in standards. But unfortunately, okay, again, standards, system and software engineering standards are mostly process standards, and they will not give you a guarantee of achieving the quality, cost, and schedule objectives. Okay, so contrary to the law of nature, okay, law of nature will give you a guarantee by definition. Okay, the Ohm's law gave you a guarantee. Okay. For each input, there is a predictive output. It's not the same in software engineering, right? But the correct use of appropriate standards should increase the level of confidence of achieving the objectives. Okay? So in other words, you're putting the chances on your side. In other words, you're reducing the risk of delivering software with not all the functionality, with not all the quality characteristics, and by busting the budget and busting the schedule. So you are putting the chances on your side. So there is a wide portfolio of SC7 standards just to show you around. Okay, so we have a standard about vocabulary. We talked about the body of knowledge a few minutes ago. There are life cycle standards, and by life cycle we mean from the beginning to the end. And I'll show you an example in 2-3 minutes. Naturally, the 29110 standards fits into the life cycle category. We have standards about documentation, about requirements, about architecture, about testing. And I stop here for a few seconds. The 29119 series, okay, and there are about 6, 8, or even 10 standards in that series are available from ISO and also from IEEE. So if you are testing, or if you are teaching testing, you should have a look at the 29119 series. There is a standard about maintenance, about project management, about risk. There are standards about measurement, about quality, about size measurement, and about tools and methods. So we cover the whole spectrum. Okay, there is no, you don't have any, you cannot say, no, there is no standard for my job. Yes, there is a software engineering standard that addresses everything within software engineering. They're not perfect, okay, but every 5 years or so, they are being improved. Every 5 years or so, there is a new version that is being produced, that is being reviewed and published, because we're learning. So we're learning, and as we capture the new learning, we provide an updated version of the standard. So this is the standard that covers the life cycle. By life cycle, we mean from the moment you have an idea and you want to acquire some software until the time that you dispose of that software. So that could be, the time between those two could be a few years. And as I showed you before, it could be many decades between the time that you have been asking a supplier to develop a software for you, the years that you've been operating and maintaining the software, until the year that you get you remove the software and sometimes you replace it with something new. Okay? And this is why we call this standard covers from cradle to grave, okay? Every aspect in a life cycle. Okay, now let's talk about 29110 for a few minutes. So again, it is part of the SC7 subcommittee, and my working group is responsible for the development of standards for very small entities, and I'll give you the definition in a few seconds. And the flags that you see there are the flags of the country that are participating to my working group. And here I must say that Thailand has been involved in development of 29110 series since the very beginning, since 2005. The first time that I visited Thailand, we were invited by the Software Promotion Agency. In those days, it was called SIPA. And we were invited to attend a workshop in Bangkok with experts from different countries to launch the working group, to launch the work, define the work of the working group. And since 2005, Thailand has been very, very involved at each step of the process, and is still very involved at each step of the process in the development of standard. And one of your Professor Laporte has been attending our meeting, our Zoom meeting for the last year or so. Okay, so so you should be proud because you have been involved from the beginning, and there are people, and I will show you. I think I have data later on to show you that your country is quite involved in certifying VSCs in Thailand. Okay, so the importance of VSCs, again, the definition, it could be an enterprise or an organization or a project or department having up to 25 people. So this is the sandbox of the 29110 series. So we're talking about, it could be a large enterprise, but in large enterprises, you have also small departments and small teams having up to 25 people. So an example of a real company, it's a Japanese manufacturer selling electronic products over the world, and this is their pyramid of suppliers. So at the top, you have that Japanese company that I will not name, and then that company gives contract to 60 prime suppliers, to 600 suppliers, and they have 6,000 low-level suppliers. And a few years ago, one of the low-level supplier producer produced some code component with a defect that was not detected, and that component was integrated and eventually sold around the world by the manufacturer. And this was the cost of fixing that defect, $200 million. Okay. Sometimes it's impossible to fix it. As an example, if you send a spaceship and because of a software error, you lose the spaceship, then there is no correction to do. Okay, you've just lost $1 billion. And if you look at the literature, we have lost many space components in space, or space components that have crashed because of software defect. So the message is there are VSEs at each level of that pyramid. So even at the top, okay, I was presenting before the pandemic, I was in Paris presenting 29110 in a workshop, and I had people from very large French companies that are in the aerospace and the space domain, and they were attending my workshop, and I asked, just for fun, I said, are you in the right room? Because here we talk about VSEs, and your company have 10 or 20 or 30,000 employees. And they said, yes, we know that, but you know, we have, for large projects, we have large processes, but for small projects with small team, we have no processes. Because if we give the big process to the small team, it's going to kill the project. So 29110, since it is using the practices, the proven practices of published standards, so it speaks the same language. Okay? We have the same organization as a large process for large project. So if we have a team of 5, 6 people, then 29110 could be the best choice for small teams. So are there many small organizations around the world? So this is an example of the European countries. So you can see here that about 98% of companies have up to 49 employees. So they have micro enterprises having between 1 and 9 employees, and you can see the number percentage is 92%. So, and the large organization having up higher than 250 employees, they represent 0.2%. Okay, so in every country there is a pyramid similar to that. Say for every large organization, there are thousands and thousands of smaller enterprises. Sorry. So in 2005, when we were in Bangkok, because we attended 2 workshops in Bangkok in 2005, one in March and one in September, I proposed that we should be doing some survey of VSE to identify their needs and what they wanted from us. So one of their needs was that they wanted to get some recognition, some certification, and they wanted to have a large majority of them wanted to have either an ISO certification or market certification, and only 4% were interested in a national certification. And they wanted also guidance, example, lightweight standards with templates and things like that. Cool. So that was it back in 2005 when we kicked off the working group. So what we developed a series of guides with, as a foundation, 2 processes, and I will give you an example in a few minutes. The processes are the project management and the software implementation process. So my question to you, why did we include the project management process? Because you may say, no, this is a software engineering guide or software engineering standard. It should talk about just the technical part of the development of software. Why are we including a management process? Okay. And the reason is this, is even if you have bright technical people, if the project is not managed properly, it may never deliver what the customer wanted. It may never meet the budget, may never meet the schedule, and sometimes it may even never deliver all the functionality. So knowing that, and knowing also that the technical people, most of the technical people don't like to do management. So we said, if we don't provide a project management process, then we'll not be doing our job. Okay, they have to work hand in hand. Okay? So you have to learn, and it's not complex. Okay? If you have learned, if you have read the 29110 guides, it's not complex. So what we have done is we have provided a roadmap of with 4 profiles, 4 guides, and by profile I mean it's like wine making. You assemble from different types of wine to such that it will meet your taste. We did the same thing. We selected out of published standards what we wanted for each one of our guides. So the entry guide is for startups or very small projects, 6-person months project. as an example, typical one semester student project. Okay? Basic profile for a VSC that has one product working and one team working on one product. Intermediate is for a VSC that is working on more than one product with more than one team in parallel. And the advanced is we want to help VSCs in being competitive and growing. Okay? So let's have a look at one of the guide. Let's look inside. So imagine you have a customer that knocks at the door of a VSC with an agreement, proposed agreement, a list of need, a statement of work, and the VSC will make a decision if it wants to do the contract or not. Let's say it says yes, then it will automatically trigger the project management process. And the first activity that will be performed is the project planning. So once the project plan is approved, then it will be executed. Okay? And that means that we'll be executing technical activities, starting with what we call the implementation initiation. So this is typically a kickoff meeting where the project manager will meet with all the member of the team. We'll discuss about what is the project plan, the schedule, the deliverables, what has to be developed for that particular customer, which process will be used, which templates will be used for that product. So that's a little meeting that may take 15, 20 minutes. So everyone is on the same page and we can start the project. And the rest are the typical software requirements activity. And as you perform the project, you evaluate your progress against the plan, as an example, against the schedule and things like that, against the budget. And eventually you will be ready to deliver your product to your customer. By product, I mean not only the code, but also the documentation that the customer requested. As an example, the customer may have requested user guide, installation guide. Okay? So you'll be delivering that to your customer. Now, the white boxes that you see in those two processes, even though I've shown them in a sequential fashion, it's for illustration purposes. See those white boxes as Lego bricks, Lego blocks that you can assemble using the life cycle or the development cycle that you prefer, or the life cycle or development cycle that is most applicable for that type of software project. Okay, so it's not because I'm showing you sequential activities that you have to use them in that sequence, right? So let's have a look at the internal of one of the activity. Let's have a look at the requirements analysis activity, and let's have a look at one task, just one task. So at the high level, we have processes. At the lower level, we have a set of activities, and each activity is composed of a set of tasks. And this is one task. And this is exactly what you get from 29110. This is a copy paste of exactly one task. So on the left side, we show you the roles. So for this task, the customer and the analyst are involved in the validation and the approval of the requirement specification. And there is some text that explains in more detail what it is. And the input that is required to perform this task are the verified requirement specification. And the output of that task will be the validated requirement specification, as well as a document or a little report called validation results. And I'll show you the result in a few seconds. So if you have been doing some cooking and you've used cookbooks, this is similar to a cookbook. Let's say you want to cook a chocolate cake, then you follow the recipe. You have a series of steps. You have the tools that you need to do for that step, and you also have the list of ingredients, the amount of each ingredient that you have to use for each step of the process to develop a good chocolate cake. Same thing here. Okay? Each activity is composed of a list of tasks showing what you have to use as inputs and what you'll be producing as output. And for each input and output, we provide you with a template that describe what should be in it. So for the validation results, we say that document, which could be an electronic document, by the way, may contain the following information. Okay? And it is this process, the software implementation process, that is like the customer of this document. So again, going back to the cake courses that I presented you before, once you have written the validation results, then that document could be used in court in front of a judge to demonstrate that the validation has been performed with the customer or with the customer representative, and all the things have been done correctly, so that the customer cannot accuse you of not doing things because he has approved the list of requirements, right? So this is why sometimes this is not the where you want to go. You don't want to go in court, but like anything, okay, things can go mad, things can go bad, and if you have in your pocket, okay, in your computer, all the evidence, then chances are on your side that the judge may rule in your favor. Okay, so what I want to say with this slide is the quality assurance practices in the House of Quality. So those that are listed in red are embedded in 29110. So in 29110, we don't have a verification and validation process, but we have verification and validation task, and I gave you an example a few seconds ago. We don't have a risk management process, but we have risk management tasks. Okay, so those are embedded in the two processes to make it simple to use. Okay, but be aware that a large number of quality assurance practices are embedded in 29110. So just to give you an idea of 4 organizations that have used 29110, there are hundreds of them, but just for purposes, let's have a look at 4. So I've been to Peru many times to talk with those people and work with those people and teach courses in Lima University. And a startup of 2 graduate students of the master degree in software engineering hired 2 other people, and they created a startup in 2012, almost 10 years ago. And they used a basic guide with sprints, okay? And they developed an 882-hour project with 18% rework. A small cosmetic developer in the area of Montreal, just 1 software developer using the entry profile, small project, 12% rework. Another startup, 2 developer, 990-hour project, 12.6% rework. And I told you that even in large organizations, you could have small projects, small teams. So here it is an example of a very large organization. It is the organization that is providing electricity to 8 million people in my province, in Quebec. And in that organization, there is an IT division of about 2,000 people supporting about 2,000 applications. So this is a very, very large organization. But as I said, they have small teams. And an example here, team of 11 people that developed a web application using a basic profile with 4 sprints, 1,500-hour project with 9.6% rework. So why that? Why am I showing you that? Remember this curve that I showed you a few minutes ago? So if you position the Peruvian startup, the other startup, the cosmetic company, and the utility provider on that curve. So what I want to show is by using proven practices of standards, instead of having a high level of rework, you have a low level of rework. In other words, you're using proven practices so you don't reinvent the wheel and you do things right the first time, most of it, right? Nothing is perfect for the first time. As an example, if it is the first time that you cook a chocolate cake, maybe it will not be perfect the first time. Okay? But the second time it will be better, and the third time it will be even much better, and then you will be happy for the rest of your life about your chocolate cake recipe, right? So the message is by implementing proven practices of 29110, you have accelerated the maturity of your VSCs. Okay? Instead of learning from scratch, okay, instead of making all the mistakes that other people have made before you, you are using the lessons learned from the proven practices. Okay? So this is the message. A quick look at the portfolio. We have many standards and guides, and I want to look at 2 of them. The Agile Software Development Guide that has been developed by experts in Mexico. We have received 2 2 weeks ago, the first round of comments. We have a few comments, but those are minor comments. So there are not major comments which says we shouldn't do this, we shouldn't do that. No, those are minor comments. So my 2 co-editors from Mexico are presently working on the comments to make modification to the guide. And we should be reviewing those comments at the next meeting of Working Group 24 in the January timeframe, if my memory is right. And if we are happy with the correction done by the 2 co-editors, then we will approve that the Agile Guide will go for a second round of review. Remember the 37, 38 countries that are participating, then they will be making final review. And eventually, once we correct those comments, then it will go it will be published by ISO. And we have received a few weeks ago, we have received a few first draft of our DevOps guide, and we're presently reviewing it. And in a few weeks, we should have a meeting where we will discuss it and make a decision about if we send it for a formal review within the C7. And also, we have a certain number of documents about the space domain. There are 6 space agencies that have requested to use 29110, the basic profile of 29110, as a foundation to help VSCs that develop software for 6 space agencies around the world. So we are developing a standard on the left side that will allow those space agencies to conduct audits or assessment. And on the right side, we are developing a guide, and the experts that are presently developing the guides are the people from our colleagues from Japan. And we should be looking at their draft guide in a few weeks. So now that we have provided to VSCs all over the world standards and guide, we ask ourselves in 2018, how satisfied were the customers, the VSCs, the auditors, and the professor with the guides and standards that we have developed. So we conducted a survey and we gathered data about the productivity. So we asked them, how long after you implemented 29110 did you notice improvement to your productivity? And if you can see the bottom, you can see the first month, the first 3 months, the first 6 months, a lot of VSCs that answered our survey noticed improvement to productivity. Same question about quality, okay? Similar answer. So in other words, it doesn't take 2-3 years before you see improvement to your productivity and quality. It is within the first 3 months, first 6 months that you see improvement. We asked them, we asked VSC, were you satisfied with your implementation? And 89% said they were completely or largely satisfied with the implementation of 29110. Now we have happy VSCs, okay? We have happy VSCs. Now we wanted to find out if we also add happy customers. So we asked the same questions to customers of VSCs that have been using 29110, and you can see 79% said they were completely or largely satisfied with the product delivered by the VSCs. So now we have both happy VSCs, happy customers, and a happy member of WG24, because we have been working for them for many, many years, and we are very happy that we have made an impact, significant impact in industry. And also we asked the same question to people from academia, and we asked them, why are you teaching 29110? Or we also asked them, why are you using 29110 for students projects? And here you can see that it is a document that could be used to teach or support the teaching of software engineering, of project management, of quality assurance, and also to teach 29110. We also asked them, since when? Okay, they've been teaching 29110, and here I put 2009 because when I was invited to teach at Chiang Mai in 2009, it was the first time that I presented in the software quality assurance course the teaching about 29110. And since then, over 10 universities of Thailand have been teaching 29110. So if you want to learn more, please have a look at at my website at the university. You'll have information in French, English, and French. Success story about the teaching of standard. I'm sure that there are success stories in Thailand, but I took one from Mexico, from my co-author of the paper, from Mirna. So they have developed in Mexico a method to accelerate the implementation of standards. But what is innovation? The innovation here is it is that they have implemented the standard not only in VSEs, but also in universities. Okay? This is quite an innovation. So they are using software development centers of universities as an environment where they are implementing 29110, and also they are getting certified. Okay, I'll show that in a few minutes. So SDCs are where students work in teams with 29110 and work with real customers, either internal to the university or external to the university. And in one university that I've discussed with, they even sell the software to the customers. Okay, so they work in the 29110 environment in a team. So far, there are about 10 universities of Mexico that have been certified to 29110, and they're being certified exactly the same way as if they were a commercial VSE. The same auditors, the same process, exactly the same. They get the same certificate. Okay, and VSE that hired graduates from those SDC were very satisfied with their new employees because I'll show you later on all the advantages of using and teaching 29110. So elements that have accelerated the adoption is that many of the documents are freely available, especially the management and engineering guide. Many of them have been translated in different languages: French, Spanish, Portuguese, Czech, and even something in Spanish. I'm not aware if 29110 has been translated partially in Thai, but if there is some Thai document, I would like to know. And also 29110 was adopted by many countries as a national standard. I know that the Thai government for many, many years has promoted to their VSE that they should be using 29110, and I see your professor nodding her head. And I remember many years ago when I was talking to École, that the government was promoting to VSEs how to adopt the 29110, and in order to lower the cost of adoption and lower the cost of certification. And that has resulted in hundreds of VSEs from Thailand to be certified. Okay. And also teaching material has been developed. So here we have a list of countries that are teaching 29110, and yes, Thailand is there on the list. Okay. With at least 10 universities that I know. So we also conducted a quick survey of software engineering professors when we wrote that article. And we asked, so when I say a subset, 30 professors, okay, we know that we're not covering the entire population around the world, but just for our knowledge, we asked them 3 questions. The first question is, why do you think there is a lack of teaching at universities? Second question is, what are the benefits that can be obtained when teaching? And third question, what needs should be satisfied to enable professors to teach standards in universities? Okay, all of them were important questions to ask. So the first question, why do you think that there is a lack of teaching? One, you can see the answer, standards are difficult to teach. Yes, I would say, okay, because I've been teaching in software engineering for 25 years, that teaching 12207 or teaching quality standards in theory in class is very difficult, okay, because it is written in a language that is good for lawyers. Okay, so it's not very good language for professor to teach. The only difference is with 29110, we have material that could be used for teaching. When I say material, we have the management and engineering guide, which are used for teaching. Standards are expensive, yes. The time to teach is too short because they were given by their university too short period to teach standards. There is a lack of knowledge about the benefits of standards by professors, a lack of knowledge about standards. They think and it's perceived as boring topics. And I agree with them that if you teach 12207, it will be like a sleeping pill. Okay, if you have this, and as I say as a joke to my students, if you have trouble sleeping at night, if you are stressed, open the book about the one standard and start reading 12207 or other standards, and I would say that within 10 to 15 minutes you will fall asleep. Okay. Okay. Number 7, standards are not included in the curricula of universities. What benefits can be obtained? And this is very important. Okay, very, very important. So students develop higher quality software on time and within the resources available. Okay? Students develop a comprehension that standards could help them. Okay? Standards is not bureaucracy. Standards are not their enemies. Standards are their friends. Standards are there to help them. Okay? Students have improved their performance, both in productivity and quality. Remember, if you're using proven practices and if you lower your rework, then by definition, you're more productive. And if you're doing things right, your software should be of higher quality. Students also discover that it's not only coding. Okay? Coding is important because without code, you don't have any product. But there are many other things before coding that has to be done correctly to get the proper code delivered to your customer. Okay? Both the management side and the software design side. Unfortunately, in many universities, the focus is on coding and testing and coding. And by using 29110, they realize that software engineering is much more complex and involves different disciplines, different expertise. Okay, number 5, students develop their ability to work as a team. Okay, because for any software development project that is ambitious, it has to be done in a team. And students are better prepared for their career as professional. And students that have worked with standards have been placed in quality department in companies of university that have been teaching 29110. Okay, so those are very positive things for students. The next question: what should be satisfied to help professors? Okay, so professors should be trained in standards so that they will be able to teach them. Okay, because standards are not easy to understand. So it's normal that we have to provide help professor to understand standards. So we have to allow professor to have enough time to teach at standards. By teaching, I do not mean showing a few slides. Okay, by teaching, I also mean doing exercises and most importantly, doing a project. Doing a project from the beginning to the end with a theme. Okay, that is when people will embed in their brain the importance of every activity, every task of a guide like the 29110. And they will realize that if you skip a few tasks, then you are increasing the risk of your project. Okay, because what has been embedded in 29110 are the minimum tasks to develop quality software within schedule and budget. Minimum. Okay. We say that we should have specific places to develop software project. By places, we mean like the university where they have SDCs. Okay, they have like a laboratory where students are trained and are using in like a simulation of a real environment, the development of a software product, internal or external to the university, and also improve the collaboration of university with industry. Okay, this is important because this is how professors discover that the needs of industry, and sometimes also this is when the industry discover that standard can help them. So how can we help professors to teach software engineering standards? Sorry. So we know, okay, because I've been in that business of being professor, that you are being rewarded because you publish many articles and you go to and attend and make many conferences all over the world and things like that, and you bring money, research money to the organization. So this is where professors are being rewarded, okay? But rarely for the quality of the courses. So one of the solutions is resources and time have to be allocated to professor to prepare teaching material, okay? Because it takes hours. It takes long hours to prepare teaching material, good teaching material, okay? Probably professors should be participating in the development and implementation of standards. And those should be rewarded because this is professional work, okay? It is research, okay? Researching what are the difficulties, researching how we can improve the standards, how we can improve the implementation of a standard in a specific culture. This is pure research activity. So professors should be rewarded for that. Standards are difficult to understand and implement. Okay? As I said, those standards are written in legal documents, and they don't tell you how to do things, they tell you what to do. So we see, and this is what we did in WG24. We invited observers to attend our working group, our Zoom meeting working group, and a professor from Thailand have been attending our meetings. So it is one way for us to transfer the knowledge between the members, working group members, and people from academia. So after attending a few meetings as an observer, then a professor can ask his country to become delegated as an expert and represented as an expert of its country to become, let's say, full member of, let's say, working group 24. Okay. A member of working group, like myself, my working group should provide support to professor. And this is what we do, and this is what I am doing this morning also. And local companies should be invited to interface. Okay. So, such that from both perspectives, from the perspective of academia and perspective of industry, we get a better knowledge about why we use standards and the difficulties in implementing standards and the success stories of standards. Okay? So this is what I was doing with my courses, inviting guest speakers from industry. Okay, so in addition of professor talking about standards, you could have people from industry talking about their own expertise. Standards are expensive. I told you before, very expensive, very, very expensive. And the solution is that university provide access to professor to membership to professional society like the IEEE, because the IEEE on their website, if you're a member of IEEE and you have access to IEEE Explore, then you can download the IEEE standards, the standard which have the triple logo, the ISO, IEC, IEEE standards. If you have standards like that, like the 12207 or other standard, then if you have access to IEEE Explore, you can download freely at no cost those standards. So the students also can download those standards freely. So conclusion, I've shown you one little box, okay, and not completely. I've just showed you just one aspect of that box about standards and models. And again, software engineering standards can help to prevent errors, defects, and failures. Okay, and I stress that here can help to prevent. It cannot guarantee, but that's the best we have, and that's the best we will have for the next 10, 20 years. Okay. Don't expect miracle. Now, our marketing pitch for me, with my colleague at TTS, we have written 2 French books on the left about quality assurance. That was published about 10 years ago. And more recently, IEEE Press has published an English version of our book. So they have translated the French book in English, and we have made naturally some improvement, and it was published in 2018. The good news, again, if you're a member of IEEE and you have access to IEEE Explore, you can download the book, the 13 chapters of the book at no cost. It's free. Okay, if you're a member of IEEE Explore or your university has a membership to IEEE Explore, you can go to the IEEE Explore and download each chapter of the book free. Good news, maybe not for you, but for me and for the community, translation in Spanish that has been completed a few weeks ago by the professors of Latin America. And the objective is to, again, lower the bar, lower the difficulty to understand the book but for Spanish reading students. And also, there is a Chinese translation that will start in a few weeks and should be published in 2022. So the message here is that software quality assurance is gaining speed, gaining attention, gaining visibility, okay, by being available in 4 languages soon. Okay, and so if people in China puts the effort, the energy, and the money to translate a 600-page book from English to Chinese, it means that for them there is some benefits. Okay, again, the bottom line, there has to be some benefits, economical benefits to the country, okay? Because that translation will cost tens and tens of thousands of dollars and will take some time and will take the expertise of software engineers to collaborate to the translation of software quality assurance. So it means that those countries have realized that if they teach and if they transfer software quality assurance practices to their universities and to their enterprise, then they are increasing their probability of delivering quality within budget and schedule. So conclusion, not teaching standard to students should be considered a malpractice. Okay, period. No question. The correct use of standard increase the confidence of delivering all the functionalities, all the quality characteristics within budget and schedule. Okay. If software engineering professors do not teach software engineering standard, then I put in quotation mark here that sentence. We could be in for another lost decade. By that I mean, since standards are documenting knowledge, proven knowledge, if we don't teach them, then we're losing the opportunities. Okay, and we're losing time. Okay. And the 29110 standards series was developed specifically for small organizations, and we have a roadmap, 4-stage roadmap from startups to grown-ups. And the last word is not only professor and student, but also developers and managers must use the knowledge that has been documented in software engineering standard. Okay? Because it's for them that we have developed those standards for the people in industry. So before I leave, I would like to leave you and your professor with 4 questions that we can either discuss during the question period or after the question period. Why do a large number of organizations either ignore the existence or don't use practices that have been available since the 1970s? So as an example, software inspection has been developed by IBM at the beginning of the 1970s. And in 73, 75 timeframe, it was published in IEEE publications. Okay, so the IEEE document has, let's say, publicized the fact that IBM has developed a very powerful technique to identify defects back in the 1970s. So that's 50 years ago. Okay, why are there so many people not using those proven practices? So why are so many people not working smarter by using proven practices? Okay, because this is if you're smart, you shouldn't be reinventing the wheel. Okay, you should be working on creating new products. Okay, being more innovative. Okay, don't reinvent the wheel. The standard have captured those things. Why are so many managers and developers not learning from their mistakes? Okay. And my hypothesis is because managers and developers have a big ego. Okay. By that I mean, oh, I am a senior software engineer. I don't have to follow a process. Oh, I'm a senior guy. I don't need to use a checklist. Oh, I'm doing such a great job that I don't have to have my documents reviewed by my colleagues. Okay. Those are manifestations of ego, big ego. So last slide, if you are looking for a first job or your next job in industry, I have a few suggestions to you. Select an organization that is using a documented process to develop their product. So if you are going for an interview for a job, your potential employer is interviewing you, but you should also be interviewing your potential employer by asking that interviewer to show you their process. Okay? Because you don't want to work in an organization that is in chaos. you want to work in an organization that is well organized. So you can trust the word of the potential employer, but maybe you can say, show me the proof. Can I have a look at your process? Second, select an organization where doing review is used as essential, not as a waste of time. Software review is the most powerful technique to identify defects and eventually correct those defects. I say again, the most powerful technique ever developed to identify defects and eventually correct them. So it's not a waste of time. Select an organization that has already improved its process, tools, and training. And this, you can ask a question to your future employer. Please, can you tell me for the last 6 months or 12 months, which improvements you've done to your process, tools, and training? Select an organization that measures its process and the quality of its software product. Remember the question that I asked, that I showed you at the beginning of my presentation about the cost of quality and the cost of defects injected, detected, and delivered? You should be asking your future employer to show you their data. Okay? And the last one is select an organization that will allow you to learn from your mistakes and as well as learn from the mistakes of other people. By that, I mean software development has risks. All software projects have risks. And by definition, if there are risks, then there are opportunities to make mistakes. So for mature organization, making mistakes is okay. Okay? Making mistake is okay as far as we learn from them and we don't repeat the same mistakes again. So a nice culture, a very good mature culture is a culture that is using the processes, it's measuring the process, measuring the quality, and it's allowing you to make mistakes and learning from your mistakes. Okay, so that's all I had to say this morning, and I think we're there, ready for questions.
Okay, thank you, Professor, for your time in sharing us the session. And I received the questions from our audience. I already typed in the chat the first question. Maybe this question come from student. I am quite new. Yes, for the software engineering, there are so many standards for the software. He means like the new version, the better version. Do you have any idea to let the software engineers or the software developers to update themselves?
Unfortunately, I will say again, life is a bitch. Okay.
Yeah.
Life is a bitch. The good news. Okay. Good news. Not in ISO, unfortunately, and I don't know why, but in IEEE, when IEEE publishes a new version of a standard. As an example, there is a standard about software verification and validation, the IEEE 1012 standard. When they published a new version, they publish also what we call a red line version. Mm-hmm. And it is like a tracking mode. Remember when you work in Word, in tracking mode, when you see what has been deleted, what has been replaced, added. So when they publish a new version of a standard with IEEE, you can also download the red line mode such that you can see much more fastly and easily what has been changed. So this is one tool to help you. Now, most of the time from one version to another, especially when the standard has been published for many, many years, as an example, the 12207 for software lifecycle has been published originally, if my memory is right, back in the 2008 timeframe or so. So when you have the third or the fourth version, from one version to another, it's only small increments, okay? Small delta, small improvements. So it's not a major change from the previous version, okay? Because the standard is quite stable. So this is the good news. Okay.
Okay.
So
yes. Sorry. Yes.
First. No, that's okay. We can go to the second. If I think I answered your question correctly. Now, one way that you can do, let's say in an enterprise, let's say you're working in a small company and you have to use a specific standard, then you could have a discussion group amongst yourself, okay? It's like reading, like a book club, okay? A book club where you will be sharing your feelings about a new thriller or a new book. then you could have a small session with your colleagues to discuss amongst yourself what is new and what are the impacts of those new things or the changes on your process, because this is the bottom line. Okay? In the company, most of the company, you will not be using the standard by itself. You will not be using the 12207 in your daily activities. You'll be using the process. Okay? In the process, you will have embedded the practices of the standard. Okay? So if you look at 29110, I didn't cover that, but in 29110, there are practices from 12207 that are embedded there. But we don't show them, we don't say, oh, these practices come from this part, these practices come from the other part, because it will be too big. But mind, in a process, your process engineer or the process expert have embedded the practices right there for you to be used. So it should be discussed, okay? So in other words, the changes in the standard should be discussed and the decision should be made about are you going to implement the changes in your process? And if yes, how are you going to implement it? What are you going to modify in your process? Are you going to add a new task? Are you going to add something in a template? Are you going to add something in a checklist? And eventually, if something is substantially new, then maybe you have to add some training to the staff to tell them, oh, listen, this task is new. In that template, we have modified these things such that everyone knows what is the newest version of the process. Okay, so we can go to question number 2.
Yes, the number 2 maybe come from our student. He said, like, due to the time limitation for the software development, can you recommend about the trade-off between quality and like the concept of the just make it work software? Because they are on the project timeline, maybe this is the question.
Yes. So don't forget, if you put yourself in the shoes of the customer, because the bottom line is the satisfaction of the needs of the customer, so the requirements, because the customer may not specify the requirements because the customer does not speak that language. Okay, customer will say, I want this, I want a tool to do this, I want a software to do this and this and that for my business. And you will be transforming those needs into requirements, right? So the bottom line is you have to satisfy those needs. There is no way around. Now, maybe if this is a large project, maybe there is a trade-off. Instead of going and using the waterfall approach and developing everything and delivering in 6 or 9 months the complete software product, maybe, sometimes it's not possible, but if it is possible, maybe you could have iterative delivery. You can deliver a certain number of functionalities to your customer, such that the customer will start using the tool, okay? Will start also giving you some feedback, okay? And most probably, okay, since we are not perfect, there will be defects that will be discovered by the customer, so that you will be fixing those defects. And when you will be delivering a new increment with new functionalities, we will also have fixed the previous iteration, the previous delivery. So this is the trade-off, because at the end, you have to deliver all the functionalities, with all the quality characteristics within the schedule and the budget. Okay? So you have to find with your customer his needs, okay? And you have to find a compromise. Okay? There is no perfect answer to this. The bottom line is a compromise that will meet the needs of the customer as well as the capacity of the VSC to develop that software product within some schedule and some budget. So I hope that I answered that question number 2.
For the third question, oh wow, do you think teaching software standard for the third year student is too late, or should we teach them since the first year? Do you have a practice?
Okay, yes. Okay, if you remember the SWE-book, the software engineering body of knowledge, it says that there are 15 knowledge area So let's say we have the requirements. There are something about architecture, about management, about process, about blah, 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 blah. Okay. So if you're taking a requirements analysis course, right, then you should be learning about the 1 or 2 standards that cover that topic. Once you get to the architecture course, there is at least one standard about software architecture. Then within the course, you should be learning about that standard. You should be doing a few exercises, and maybe you should be doing a few a project, okay, to learn about the standard. Okay, standard. It's like learning to drive a bicycle. Okay, the first time it's not easy. Okay, the first time you may fall. The first time you may hurt yourself. But if you don't do it, you'll never learn. So you have to jump on the bicycle and learn to ride the bicycle. And remember, there are safety wheels for the kids, the little kids, to prevent them from falling. So the safety wheels is the safety net at the university. The safety net is provided by the professor because you are learning. So it's correct to make mistakes in the university because you're learning. Okay, so it's better to make your mistakes there. You should be making your mistakes there than making the mistakes when you're working in a company on a real project with a tight schedule and a tight budget. So yes, for each course, remember the SWE-book as an annex that points to you the standards that are applicable for that part of that knowledge, for that knowledge area. So in other words, each course should expose the students to standards. And I would suggest, because this is what I do, is the software quality assurance course comes at the end of the curriculum, because if you use, as an example, the 29110 to do a student project, so you have a win-win in that case. In the class, you teach the software quality assurance practices, and in the project, the student will apply those practices. Okay, and students will realize that the knowledge that they have acquired in the different courses, the requirements course, the architecture course, the maintenance course, the testing course, etc. All those pieces is like a puzzle. They fit together in the software quality assurance course when they do a project. They see with 29110, they see the links. Now they see why they have to do this. Now they see why they have to do reviews. Now they see what are the links between the software requirements and the architecture and the code components and the test cases. Everything fits together when they do a project with, as an example, 29110. So I hope I answered this question correctly. Do we have other questions? I don't hear you.
Sorry, Professor.
No problem.
For the audience who have a question or want to say something, one thing. If you have a question more than you cannot think at this time, so you can give the question to me and I will send to Professor. And yes, for the audience who have something to say to Professor for today.
So while you're thinking about that, if you are interested about the House of Quality, I can provide you with a webinar like we did this morning. Okay, so when I say this morning for me and the evening for you, so if you want to cover an element of the House of Quality, let's say software reviews or verification and validation, we can do a 1-hour webinar about that later on. And if you want to have, let's say, an overview of the House of Quality, we can do that too. So that could be one way to see from a different perspective software quality and software quality assurance practices. Because you asked me at the beginning if we can work together, and that could be one way to work together. We can have occasional webinars like that on a specific topic.
Yes.
So do we have other questions or comments before we close?
Okay. Have any questions?
It's okay.
Okay, so Professor, I think that I have many questions, but on the end of this talk, I just one question, and not actually it's not question, but it's like the final word from you. Like, could you say something to encourage or to let the Thai software company or the developer in Thai developer to realize that the software standard is very important, or why they need to know about the software standard or the software engineering practice?
I will use this slide that I've presented to you earlier, because that summarizes the why on both sides. Okay, because you have to know the advantages, and you also have to know the disadvantages, because they're there. If you ignore them, they will hit you. Okay, so by looking at the advantages and disadvantages, then you will have no surprises when you will be implementing standards. Okay, but there are many advantages to the application of standards, especially, okay, as an example, if you have many VSCs that want to work together on a large project, it's much easier to work together when they have the same process or very similar process. And this is one of the that was one of the objectives of Thailand when we developed originally 29110, was to allow VSCs that have a very dedicated expertise to get together, 2, 3, 4 VSCs together to work on a big project or larger project which has more than one discipline. So if they have their own expertise, but they use the same language, by that I mean they have a very similar process based on 29110, it's much easier to collaborate between different VSCs because they speak the same language. Okay, not only Thai, but they speak the same process language. Okay? So it's much easier to coordinate a project when you have 2, 3 VSCs that are using exactly or very similar process. So that's the bottom line again, is the economy, okay? To improve the economy, to improve the investment. Because me as a customer, okay, I don't know, okay? I have an idea, but I don't know if you will be delivering to me the product that I want. But if you can prove to me that you have implemented the process, and if you have been audited externally by external auditor, then for me as a customer, I think that I have a higher confidence that you will be delivering to me the product that I want within the schedule and the budget. So it's a matter of confidence, okay? Higher confidence for me as a customer of getting the product that I want. And this because me as a customer, I want the software to do something in my business, or me as a government organization to provide services to my citizens. So one way or the other, if I buy a software, it's because I want to have some benefits, some economic benefits as a company, or benefits for my citizen as a government agency. So standards are essential to those, and standard also will allow you to be more innovative, because you won't have to think or reinvent the wheel about how you will be developing your new idea. Your new idea will be developed using the process. So you'll be focusing your energy on the functionality, how to make that product or that idea a better product, getting more customer attracted to that product, and you'll be using your day-to-day process to develop your product. And when you'll be hiring a new employee, because you may want to grow, then I don't, maybe you do, but I don't do telepathy. So you don't transmit a software process by telepathy. It has to be documented. So you can show like your cookbook recipe, you can show to your new employee the process, and you can show to your employee the role that they will be playing in the project, and that new employee can become on board, can be much more productive, much sooner. Okay, because he knows what is it's a role, and as well as the role of the other people within the team. So there are many benefits to standard, and you have to look at the things on the right to minimize those, okay, and optimize the one on the left. So that's all the final words I had about standards.
Okay, good.
Thank you.
Yes, Dr. Aziz, this is maybe I think it's time for Professor and for us for this sharing session. We learn a lot, and I think this is value for us. Maybe at the last session, please, Dr. Aziz, could you say something to thank you, Professor Claude?
Okay. First of all, on behalf of the Prince of Songkla University and the College of Computing, I would like to thank you and really appreciate for your talk today. It is really nice presentation, and I think many audience today also get many new things that can adapt in the future, both in software engineering area and other side of the information technology areas. Again, I'd like to say thank you very much, and hopefully we can have more collaboration in the future. Also, I'd like to say thank you, Dr. Veeraporn, for the organized this talk, and our audience for today. Thank you.
Thank you very much. Thank you for the invitation.
Thank you.
And hope we see you later. Bye-bye.
Yes, bye-bye, Professor. See you.
Bye. สวัสดีครับ
Thank you
สวัสดีค่ะ
สวัสดีค่ะ
Bye.